This is a second panel of distinguished experts in the field of wind power and impacts on issues that are of concern to the public. We're going to dig a little deeper in this session on some of the key public acceptance issues. And I've asked the panel to each take 15 minutes to really present a status of the current research on the issues of wildlife impact, habitat impact, noise, flicker, property values, and visual impacts. Now, I want to make it clear that we realize those are not the only issues that are at stake in siting wind facilities in New England. And so I would really appreciate it if during this session you would write down what other issues you believe are priorities that we need to address besides the ones we're talking about here. And we may have time to talk about what we've heard, or at least we will be able to collect that information so that NEWEEP can tee up those issues for further discussion in its series of outreach activities. I guess I should introduce myself first. I'm Mark Sinclair. I manage a nonprofit called the Clean Energy Group. We work on policy, finance, and technology in the renewable energy field around the country. And we also manage a coalition of states called the Clean Energy States Alliance, which represents 20 of the most, really the leading state-based renewable energy funds that are providing money, grants, loans, investment in renewable energy investment, and therefore have a great stake in getting it right. And I also want to say that even though I work for an organization that really does care about growing renewable energy, I also understand that we got to get it right. I actually live in Vermont in a small town in Mad River Valley where there's been a couple of years of debate over whether we should put wind towers on our nearby Northfield Ridge. And what I've learned is that there are a lot of opinions, and there are a lot of valid opinions, and there are really no easy answers or right answers, but that the discourse is key, and that discourse being informed by solid facts and research. So it's great to have this panel here who can help us learn a little more about what we know and what we don't know. Just to go through our speakers, we've got Sarah Barnum from Normandeau Associates. She's going to speak first about habitat fragmentation. Then Carol Foss from New Hampshire Audubon, who will talk about wildlife impacts. We've got Ben Hoen from the Lawrence Berkeley National Lab, who's written about and studied property value impacts. Then we've got Ken Kaliski from Resource Systems Group, who's done a lot of work around sound and flicker issues. And then Jean Vissering, who is with Jean Vissering Landscape Architects, her own firm, and has done significant work and proposed what I think are effective methodologies for evaluating the visual impacts of these projects. We have a lot of work focused on New England. We're going to have over a half an hour to answer questions from the audience. What I think we'll do is, I've got a couple of written questions already that were provided before the conference, but I'm going to allow folks to go to the microphones rather than writing down questions. Unless you'd like to write them down, go ahead, but I think the interaction could even be more vibrant if people with questions can get up and use your own words. So with that, I'm going to turn this over to Sarah.
All right. Thanks for inviting me here. I'm looking forward to talking to all of you about this. I'm going to start by presenting a general overview of impacts of wind development on wildlife, and Carol's going to follow up with some more detailed examples of studies that have been conducted here, right here in New England, and talk a little bit more specifically about New England impacts. So this first slide is titled Impacts of Wind, in parentheses, Development on Wildlife. The fact of it is that wind development is a lot like other developments and the kinds of impacts that it has. There are some unique impacts to wind, but it's important not to lose sight of what happens when you take a piece of land and develop it for any purpose. The direct impacts that occur from development are habitat loss, alteration, and fragmentation. Certain types of projects also create mortality. Wind is one of those kinds of projects that can create mortality, and I'll talk a bit more about that. There are also indirect impacts from all types of development, and they include disturbance to activities and the daily routines of wildlife, and then avoidance. If the wildlife loses habitat or is disturbed by a project, they will then avoid that area, which creates, to some degree, can create larger amounts of habitat loss. So the species that we're primarily concerned of when we're looking at wind projects, because we are putting things into the airspace, we have the opportunity to affect things that fly. Bats and birds are obviously at greater risk from wind projects than some other types of projects. However, it's also important to remember that wind is not the only kind of development that's putting things up into the sky. We also have communications towers and tall buildings that can have big impacts on these flying species as well. We also tend to kind of focus on those things up in the sky since the turbines there are a bit novel, and we forget that there's a lot of stuff happening on the ground as well. And when you construct a wind project, particularly a commercial scale one, you're building a lot of roads and other infrastructure to support that, and you're having a fair amount of disturbance on the ground. And threatened endangered species, even though they might be terrestrial, like this timber rattler here from Pennsylvania, are definitely at risk from these types of development as well. So you have a variety of species that you can be impacting through a variety of mechanisms. So wind is a lot like other types of linear developments. And linear developments that we're all familiar with include roads, power lines, and gas lines. Pipelines is the word I'm looking for. Linear developments have a certain set of impacts. Their fragmentation effects can be greater than other types of developments because they are long. They do go through a large area of the landscape. They have more opportunity to break up the landscape into pieces. Fragmentation has a number of different effects. The basic definition of fragmentation is that you're taking an intact block of habitat and you're breaking it into smaller and smaller pieces. The level of impact that fragmentation will have depends on a few different things. What are the size of the blocks you're breaking things into? How large is the intervening development that you're putting between your blocks of habitat? And then also what's the remaining connectivity between those blocks of habitat? The importance of fragmentation has got a lot to do with what the surrounding landscape looks like. If you take a huge block of intact habitat and you run one power line or one road or one wind turbine string through it, you're not having a real big impact because you've got still a big area of intact habitat around you. However, if you've got a habitat that's already somewhat fragmented and you're adding more fragmentation, then those impacts do start to compound, and at some point you kind of reach a tipping point where that fragmentation really starts to have a real impact on the habitat and the kind of species that it can support. Another important aspect of fragmentation are the kinds of animals that are using the habitat. Some species are well adapted to fragmented habitats. They naturally take advantage of patches of different kinds of habitats. Other species not so much, and so a lot of fragmentation's ultimate effects has to do with the suite of species that are present and how they respond to what you're doing to the landscape. Linear developments are also well known for creating edge effects. Fragmentation just refers to taking an intact habitat and breaking it into blocks, but once you put that fragmenting feature in, you've created an edge. And edges are well known for having a bunch of different effects, too, that are specific to an edge. Edges are often used by predators who are hunting, and they walk along edges or they fly along edges, and they look for their prey species. And so there is this avenue that creates sort of a sink where animals are more at risk from predation. Edge effects also change. For instance, if you're taking a forest and you clear, you end up with a clearing like you would for a turbine string or a road or a power line right away. Suddenly there's more light going into the surrounding forest, warmer temperatures going into the surrounding forest, changing perhaps the amount of moisture that's present, and you're going to get different kinds of plants. Different kinds of plants change the usefulness of the habitat to the species that are there. So you get this whole set of edge effects that come along with fragmentation. And then finally, you also create travel corridors for exotics. And a lot of exotic plants spread, particularly along roadsides. You've got disturbed soil, you've got lots of sunlight, and you've got a vector, meaning the cars or the people using the road to bring those exotic plants in. These impacts may or may not be really relevant for wind power projects. We create roads when we build wind projects. The turbine strings themselves are also a linear disturbance. However, they have a lot less use in traffic than a public road. So you're getting some of those types of impacts associated with wind, but not all of them. Some linear developments also have operational effects, and those are things that happen due to the operation of the project. That's mortality and disturbance. Roads, obviously, we all know the mortality associated with roads is roadkill. Wind power projects have turbines up in the sky, which animals can fly into, and so you get your mortality effects that way. Disturbance, same thing. A lot of linear projects have a disturbance effect. Wind has sort of a unique disturbance effect that we haven't seen before in terms of what is the effect of the visual effect of the spinning blades and also the sound. So just to kind of build a little bit on some of these unique impacts that wind creates that we don't see in other kinds of development. The most important thing probably is the fact that it fragments the airspace. That is something that no other project does. No other kinds of linear development will do. And one turbine probably doesn't fragment the airspace. It's something that's easy for animals to go around. But when you have a string of turbines, particularly along a ridge line that might be acting as a guideway for migrating birds, suddenly you may have created a real barrier to their movement. You may also have created something that will affect their behavior, how they approach that area and how they fly around it. And then, like I already alluded to, the novel sources of disturbance that the wind projects introduce to the environment. So how significant are these impacts? Well, that's a huge question that we don't necessarily have all the answers to, but one of the most important things to consider when you're thinking about the significance of the impact of wind or any other type of project is what's the context. And the four illustrations that I've added there show turbine strings in different settings. And you can think about how these different settings are going to have a different, modulate the amount of impact that these turbine strings will have. The six turbine strings there, the six turbine string in the middle of the farm fields there, creates a linear barrier, but it's in a habitat that's probably not used by a lot of wildlife. You didn't have to alter the existing vegetation to put these in. This area has probably been a farm field for at least 100 years, and plopping in a few more plopping the turbines in there really didn't change much about that setting. And so that impact is probably relatively small just because of its setting. You look at this picture below, you see the turbines being constructed in a forested setting. Here we're definitely altering the habitat. We're having to remove habitat. The habitat that's going to be left behind is very different. There are going to be animals who like the open habitat mixed in with the forest, but you're also losing habitat for the forested species. You also see here that there's a real potential for changes to water quality. All the cut and fill for this hillside. Building those roads is going to change the way water runs off. You're having a whole bunch of different impacts here. So this is a completely different context and probably a different level of impact. Take a look at the turbines located right along the shoreline. Here you're impacting a fairly unique resource. The shoreline is a specific area. Birds may be commuting back and forth from inland over to the water to feed and so on. And so by its position, that barrier you're creating might be very important, and you need to consider that context and take a look at the species that you'd be impacting there. And then the last picture, the turbines out in the sort of shrub steppe, probably out west somewhere. You've created a lot of roads, you're having impacts there. That small development in itself may not be terribly important in that habitat, but think about if you were starting to add more and more of these developments, you start to look at what's going to happen at a landscape. So again, you're kind of looking at your context, trying to decide what your impact's going to be. And just briefly assessing the impacts of wind development on wildlife. Carol will talk a bit more about this, but I just want to point out that there is a useful body of knowledge about the non-unique impacts of wind. We have been studying the impacts of linear development for quite some time in the wildlife community, and we know a lot about those things, and we can start to guess about what kind of impacts they create and how to mitigate them. However, we do lack knowledge about wind's unique impacts. We really don't understand how effects to the airspace might happen, how migrating birds might respond to turbines, particularly raptors. And we also lack knowledge about how some vulnerable species react to wind's unique impacts. For instance, when you start to think about impacts to bats, we don't even know how many bats are out there. There's no way to census and count bats. And so, yes, we know we're killing a few of them, but we don't know, is that 1% or 10% of their population? So there's some real basic questions that still need to be examined in order to understand what the impacts are going to be. And with that, I'd like to turn it over to Carol.
I want to thank Sarah. I didn't really introduce her adequately. She is a senior wildlife ecologist with Normandeau, and she's been doing a significant amount of studying both pre- and post-construction impacts from wind developments in New England. I think I should change careers. When I first tried to get hold of Sarah, it took days because she was up in the woods of Maine enjoying herself immensely while I was sitting in an office. And then with Carol Foss from New Hampshire Audubon, when I first got her, she left a voicemail saying she'd be in field studies for 10 days. So I'm certainly doing something wrong. We're going to continue with a look at now the direct and indirect impacts on specific species, including mortality. And we've got Carol Foss from New Hampshire Audubon to speak to this issue. She's Director of Conservation with New Hampshire Audubon and has over 20 years of experience dealing with wildlife and impacts from development. Thank you, Carol.
Thank you, Mark. If it makes you feel any better, the density of black flies and mosquitoes is probably fairly low in your office. Good morning, everyone. I'm pleased and honored to be part of this event today, and I'd like to share some of my perspectives of impacts of land-based wind energy development in New England. Sarah mentioned we have direct impacts and we have indirect impacts, and I've divided them up a little bit differently, looking at the individual organism perspective. The primary direct impact of wind development on wildlife is mortality, which occurs as a result of flying organisms colliding with turbines and affects birds and bats. We document this through mortality surveys, which not only include searches for carcasses, but also include searcher efficiency trials. I don't know how many of you have tried this, but some people are a lot better at spotting little dead animals under wind turbines than I am. So that's an important component, and also scavenger removal trials. We have crows, we have raccoons, we have crows in our landscape, and they're all out there looking for an easy meal. So it's really important when doing these carcass searches to know what the rate of removal is for the carcasses that are out there. So you go out there and you do all this field work and you get all this information, and then there are complex formulas that include the number of carcasses that were found, the searcher efficiency rate, the carcass removal rate by scavengers, the proportion of turbines searched, which in a small facility might be 100%, but if you've got a facility with 50, 60, 100 turbines, it's not practical or cost effective to search all of them, so you search a certain percentage of them. Then particularly in New England's terrain and land cover, if you remember Sarah's picture of the turbines in the agricultural area, you have a nice flat area with uniform vegetation, and if you're out there walking transects looking for little dead carcasses, you have a reasonable chance of searching the entire area. If you're on a New England ridgetop, however, you may have ledge, you may have minimized the size of the turbine pad to minimize the habitat issues, so you can't search a large uniform area. So you also need a correction factor for the areas that you can't search. And then the search interval is also an important piece. Are you doing daily searches? Are you doing twice a week searches? Are you doing weekly searches? So all of these different factors get put into a formula to develop an estimate of mortality for that facility. And I want to acknowledge Jess Costa from Stantec, who put together a summary of New England fatalities for the Wind Energy and Wildlife Forum in Orono last month. And if it wasn't for her presentation, this presentation would not have been possible, because she did a great job summarizing the available information. The slides that I'm about to show you include data from 3 sites in Maine, 1 in New Hampshire, and 5 in New York, which I've kind of included in this because there are more wind facilities in New York that have been operational for a longer time, so that data is really helpful. So this slide is just based on uncorrected factors, sheer numbers of dead birds and dead bats found at these facilities. And as you can see, bat mortality is much more common than bird mortality. If you look at the bird mortality and break it out by species group, passerines, otherwise known as songbirds, are by far the most common group involved in collisions with turbines. If you start looking at species to see if there are concentrations, for some reason, golden-crowned kinglets are the most common species to collide with turbines in New England. Red-eyed vireos are also right up there, which isn't really surprising because they're one of our most abundant forest songbirds. The kinglets is a little surprising to me because they are a conifer specialist, and I don't think of them being as abundant. But perhaps that's because most of them are further north than we spend most of our time. If we look at bat fatalities, By far, the most common species colliding with turbines is the hoary bat. And in that analysis, the little brown bat was second. One suspects that in the coming decade, this proportion is going to change because little brown bats have been very seriously affected by white nose syndrome, and so there just aren't going to be as many of them out there vulnerable to collisions with turbines. If we look at how New England shakes down in terms of other regions of the country with respect to mortality rates, the smaller reddish blocks are minimum values because these are estimates, and the taller orangey blocks are the maximum values. We're kind of in the middle. New York has higher mortality rates than we have seen in New England to date. However, these are really small sample sizes, so with more facilities on the landscape and more data available, these proportions could change. But the Southwest and the West seems to have the highest maximum, although a low minimum. So you'll see these are estimates, and there's a large error in there. Our estimates vary from site to site, and even at a given site, they're not really precise. So this is the nature of the data that we're dealing with. With bats, the Mid-Atlantic and Southeast is the area of greatest mortality, and New England is fairly low, at least as far as the data that is currently available. So if we think that the data on mortality rates is kind of iffy, it's several orders of magnitude better than what we know about indirect effects. Indirect impacts include habitat loss, fragmentation, and degradation. In our landscape, this results largely from forest clearing, as well as human activity and turbine noise. Any forest-dependent species is potentially vulnerable to these impacts, and really the best tool we have available for assessing the nature and level of such impacts is called a before-after control impact study, or the BACI, as it gets known as for shorthand. And this is a non-trivial exercise. It involves going out onto the ridge or other land area where the facility is proposed, finding another maybe adjacent ridge that is not proposed for development, doing studies in both of those areas before construction, and then doing studies in both of those areas after operation begins. So it's a non-trivial investment, but it's really the only way to assess indirect impacts. As a result, these impacts have really received very little study in northern forests to date. As we speak, there is research going on in northern New Hampshire on American marten and Bicknell's thrush, which are both species of concern in New Hampshire, at the site of Granite Reliable Powers Project in Coos County. So standardization of methods and metrics is really important to enable regional analyses of mortality data. We're getting to a point now where there's enough data out there that you can kind of begin to look for regional patterns, but we're still a long ways from understanding things at a landscape scale. Indirect impacts are really a topic that demand a broader approach than just a project-by-project approach. And right now, all we have available for funding is kind of project by project specific studies. So that's something that the wind and wildlife community is going to need to give some thought to in the coming years. With habitat loss, the habitats of greatest concern include high elevation spruce fir forest, which isn't even an issue in some of the more southern parts of New England. But ridgetop mast stands, both oak and beech, are also a limited resource on the landscape, and those would be of more concern in the southern part of the region. Degradation, as Sarah mentioned, when you open up a strip through a previously contiguous forest, there are a number of issues that develop in the adjacent forest, in spruce fir on ridgetops in particular. You open up this alley for wind so you can get increased wind throw, and your opening gets wider and wider as time goes on, even though you were very careful to cut the most narrow roads possible. Headwater streams and seeps, as Sarah also mentioned, you get a lot of road cuts in high elevation and steep areas, and that can really make a difference to the local hydrology and affect organisms that depend on those habitats. We really know nothing about turbine noise and its impacts on wildlife. That's a very rich potential area for research, but again, it really would best be done by collaboration between a number of different facilities in order to get any data that's meaningful. We don't know if the sound of the turbines masks prey scurrying around so that it would make hunting more difficult for owls. We don't know if there would be impacts on songbird communication of territory boundaries. We know that highway noise has some impacts there, but this really has not been studied in the context of wind, nor has any impact on large mammal wintering areas. So that is what we know in a nutshell, and a lot of what we don't know in a bigger nutshell. So thank you for your attention.
Thank you, Carol. I want to just note that Carol will be on a panel this afternoon, so you'll be able to get into the issue of wildlife impacts and mitigation much more deeply in one of the afternoon sessions. I also want to just make two notes on this issue. I served on a federal advisory committee put together by the U.S. Fish and Wildlife Service that met for the last 2 years with developers, state agencies, environmental NGOs, and to crank out recommendations for federal guidelines to deal with wind impacts on wildlife. And the service has put out a draft set of guidelines that you may all want to take a look at. They are very rigorous, they are very comprehensive, and in some instances, such as dealing with fragmentation from wind projects, I think they take the wind industry into areas where no other energy source has gone before. Not to say that that isn't right, but the fragmentation treatment by the service's guidelines, draft guidelines, is setting new ground for how you deal with energy development. So there's a wealth of information in that draft. You can go to the service's website. And secondly, on research, there is a national research effort funded largely by developers called the American Wind and Wildlife Institute. It's now run by somebody from Mass Audubon, Tabor Allison. It's a great resource that you should know about in terms of finding current research in this evolving area where we still have such information gaps. Now we're going to turn to human impacts, and we were able to have one of the national experts on visual impacts from wind development here with us, Jean Vissering. Jean has been working in landscape planning, design, and visual resource planning for many years, and she's the author of a number of publications dealing with wind and the impacts on the natural scene and the historic scene. Actually, she just completed a publication for us that lays out a methodology for addressing the impacts of wind on visual resources. I highly commend it to you. I thank the Department of Energy and the Wind Powering America team for actually allowing us to do this work. And I think Jean will get into some of the content of that new report in this session. She'll also be available this afternoon at a panel. So with that, Jean, thanks for being here.
Good morning, and thank you. Obviously, we're going to be turning now to looking at the issue of aesthetics, wind energy, and landscape. And I will say that my focus is going to be on looking at the impacts of scenic resources rather than on specific property owners, though we can perhaps talk about that later. But I also think that although there are a lot of challenges with respect to this issue, I think we can also find some common views. So I'm going to be outlining a few things that I think can help ensure public confidence in the process, and I'm not going to go into, I'll be going into all these items in black, but I did want to mention some of the tools that we have available to us, which include planning, siting guidelines, regulatory review, and of course the project itself, which would include the area of influence, in other words, in this case, the area from which the project might be visible. I am not going to be looking at the smaller scale turbines, but we can talk about that later if you'd like. But I will say that wind projects have introduced some very new elements into the landscape. They don't look like anything that we've traditionally been used to. And certainly by most of the measures we developed for evaluating visual impacts, like contrast, scale, visibility, if we look at wind energy projects, they are, of course, highly visible. They can't be screened. They are white. They are very large. They involve motion, so they're attracting even more attention. And frequently they are located in what we might have called sensitive areas, in other words, higher elevation areas, or in some cases, oceans. On the other hand, studies, as was mentioned this morning, seem to indicate that there is a high degree of acceptance of wind energy projects, at least conceptually. And I've even heard people say that they find them beautiful, and I think there are studies that show that, which is more than I have ever heard about people say about communication towers, and I actually have a theory about why that is. But nevertheless, the general public acceptance of wind power projects is useful for developing public policies, I think, and sort of just looking at energy planning. But what we really need to be focusing on is the issue of what are the specific characteristics of a particular project and the particular characteristics of its surrounding environment. There will clearly be projects which will be very acceptable. There will be some that will need some modification, and there will be others that will be unacceptable. And the question is, how do we make these decisions? So I want to just move on to a few topics, starting with the idea of siting wind energy projects. There are siting guidelines, which if you look If you Google siting guidelines, they're really best practice guidelines and have nothing to do with sites. But when I'm talking about this, I'm referring to locational directives. California does this. Maine has done this in the unincorporated territories, and as far as I can tell, it's working quite well. And I think it gives an idea of where wind may not be permitted, and perhaps a sense of comfort in that regard. But my own experience has been that I have been quite surprised at projects that I have found to be acceptable or not acceptable. And I'm going to give you a couple of examples. Both of them are sites near the Appalachian Trail. And if we were doing an overview, siting guidelines overview, certainly some of our state and national trails, like the Appalachian Trail, would be something we might red flag as an area of caution. So the first example is a project in Maine. It was Reddington Black Nubble. It then became the Black Nubble Project, which was denied by the Land Use Regulatory Commission, and I think for in my opinion, for good reason, and for very specific reasons. It was visible from at least 6 high-elevation open alpine summits at close range, in other words, the next ridge over, along a stretch of trail that was 30 to 50 miles from which there could be potential visibility, in addition to which this was known as being one of the most remote and scenic sections of the trail. Now, by contrast, this project is no longer under consideration, but it's visible from perhaps one small, narrow lookout with a view across the city of Manchester, Vermont, and it's located on the shoulder of a peak. So you have, depending on when you really get into on the ground, not from maps, there are a lot of differences. Okay, so I want to look next at the regulatory review process, which I think is where we really get into the crux of the issue. And I think it's also, I believe that there are good, logical processes for understanding and evaluating visual impacts, which I've articulated in this report. And I'm not going to go into too many details on that. But I did try to articulate some standards for determining when a project might reach that threshold of being reasonable to unreasonable, or passing the threshold of undue. I've also tried to establish some standards for best practice standards for trying to be sure that when we present wind projects, we are illustrating them, describing them very clearly, very honestly, in ways that the average person can understand what it's going to look like and to feel some degree of comfort in the process. So just a few examples that I'm not going to go into detail, but the area of review, which I tend to believe should be, because of the potential visibility, should be for most land areas 10 miles, perhaps up to 20 if we're talking offshore or much larger projects. Looking at being very honest when we present simulations of projects, that we illustrate the most proximate, the most sensitive viewpoints, and we do it in a way that illustrates the turbines at the size they might be. This sort of just shows 2 frames of a photograph, and then you can see how they start to look smaller as we do a panorama view. So panorama views are useful for illustrating context, but they do not show you really what, from a particular vantage point, the project would look like. And then just making sure that these are places that local people care about. Let's show them in their best light without the visual clutter in the foreground. And making sure that we illustrate roads and clearings when we show these simulations. So the third thing I want to mention is planning. And by planning, I don't mean energy planning. I mean general planning that happens at the local, regional, state level. and specifically identifying scenic resources. It is really useful to developers, to regulators, to know that what are the parts of the landscape that we care about. And planning is a process that ensures that it is there is some public consensus in the areas that are put into a plan, and especially if they're articulated. So, for example, on that Black Nubble project, the documented significance of that resource was very important. On the other hand, it's important to recognize that the fact that it's documented is not the only reason that it should be of concern. There are many other specific ways that are important to explore in terms of how the project is seen and experienced in the landscape. The scenic quality, the viewer expectations, the uniqueness of the resource, duration of view, and proximity to the project. Those are some of the variables that we might consider. So I need to mention scale because that is one of the unique attributes of wind energy projects, and it's one that makes a lot of people nervous. But of course, scale or size is only relevant in terms of its context. So how we see them in the landscape can often be very different. This is and I think probably equally important to the height is what I would call breadth or horizontal scale of turbines. So this is a relatively small 5-turbine project just approved in Georgia, Vermont. This one is a 15-turbine project, but from almost anywhere in the landscape, it's very hard to see all 15 turbines. So the size of either the turbines or the size of the project is going to vary tremendously. So in addition to which, you can see that much smaller foreground hill looks much larger than the turbines. So that's why scale is very relevant. This project has changed considerably since, but I'm using it just as a way of showing the idea of a larger project, in this case 48 turbines. But just because you may have issues of different breadth, potentially mass, depending on the size. We'll be talking about mitigation techniques this afternoon, but there are many approaches, but I want to mention a few that I've heard coming up recently, or at least that I think are perhaps useful to consider. One is, and the most obvious, is turbine relocation or reduction. This was a case where the developer said to me, well, what do you think of this configuration? And I said, well, those 2 turbines on the top of that hill in the foreground have got to go. So because it's a very prominent landform, and by removing those 2 turbines, the wind turbines not only are further back, but they appear to be smaller and lower in elevation than the foreground hills. So sometimes just simply removing or relocating turbines can make a big difference. So I want to mention FAA lighting. I've been hearing this coming up. And particularly, there was a recent case in Vermont. This project was just approved by the Public Service Board. And I was working on behalf of the Green Mountain Club, and our concerns were, in part, the lighting because of its visibility from one of the shelters. We were less concerned about the visibility from the fire tower because that wouldn't be experienced at night. But this was, and you can kind of see that the project is kind of framed by trees. And so the Public Service Board agreed to require at least investigation of a system called Object Collision Avoidance System, which would only mean the lights would only come on when a plane was overhead. Now we don't know if that's going to be approved by the FAA, but I think it's something that has made a big difference. Roads, I'm not going to get into details on this, but again, from high elevation areas where you have a sensitive viewpoint, they may be a concern. They tend not to be particularly visible from below. And finally, I want to mention a couple of things. Cumulative impacts. this is another thing I hear coming up amongst regulators and others. We're not at the point, I don't think, where we're having specific issues now because we're just beginning to develop wind energy projects. But in terms of public confidence, having systems in place for looking at this issue, I think, is going to be important. And the systems that I've seen addressing cumulative impacts of aesthetic issues have been really not at all helpful. One that I did see that looked like it might have some possibility is this Angus Wind Farms study in Scotland, where they are addressing a lot of wind projects very close to each other. And then I want to mention comprehensive energy plan. Now, the reason this relates to aesthetics is something that came up this morning. We humans tend to imbue the landscape with meaning. And when we can see direct benefits to us in the landscape, then we tend to have a much more positive view. So I think making sure that as we do energy planning, we have very sort of concrete connections between wind energy and actual reductions of greenhouse gases, that will be a good thing. And then the last thing I just wanted to mention is terminology. I like to use the term wind energy project to avoid the sort of very pastoral term wind farm, or the very industrial term industrial wind. And the same thing, being careful about the use of the word NIMBY, because I think it's a natural human instinct to be concerned about one's property. And I think actually that's a good thing. But we need to just sort of recognize that natural instinct, and rather than doing name calling. And by the same token, the fact that wind energy companies often are corporations is also not a bad thing. So thank you very much.
Thank you, Jean. When I first engaged Jean to help with, or to basically produce this report, I'd always thought that, dealing with the impact of development in our communities and on our hills and mountains was very subjective. Well, it certainly has a degree of subjectivity, but what I like about Jean's approach is that it lays out some real methodologies and criteria for how to think about, in a rational, objective fashion, what the degree of impact will be on scenic attributes that each of our communities cares about. So I commend her process and criteria to local communities, regional commissions, and state boards. We're now going to turn to another thorny issue, and that is sound, noise, and flicker. And we're lucky to have an expert in this field, Kenneth Kaliski. He is managing director of the Acoustics, Air, and Energy Division of Resource Systems Group. That's a consulting firm with offices in New England and then in Utah and Illinois. He's worked in the field of noise impact and also avoided emissions from renewable energy projects for quite some time. Ken, thanks for being here.
Thank you. So the topic of my presentation is mostly on noise and sound, but I'll talk a little bit about shadow flicker at the end of my talk. And noise has been a very high priority in terms of public acceptance. If you go to, for example, the Vermont Public Service Board, they spend a lot of time with birds, bats, wildlife, transmission, reliability, and a number of other subjects, but the topic that gets a lot of public attention in these kind of hearings is sound and noise. In in a case in Vermont that I was involved in, the amount of time essentially reserved for cross-examination of the noise and the sound witnesses was the topic of number one interest, let's say, and preceded by visual impacts. So those visual and noise are of concern to the community. In another case, I was involved in an opponent's to a wind farm. Their appeal, about 75% of the appeal was made up of issues surrounded by noise, about 20% on visual issues, and then about 5% on the remainder. So I'm going to first try to give you a very brief summary on sound. It's a complicated science. I could go on for an hour about that first subject, but I'm just going to touch upon it and then talk specifically about sound from wind turbines, and then noise regulation in New England, and then briefly touch upon shadow flicker. So I'm going to talk a lot about decibels today, and our human, or the decibel levels that'll talk about are mostly A-weighted sound levels. And to try to get you into what an A-weighted sound level is, I'm going to try to get a cursor up here. I put the graph together. The horizontal axis here is a frequency going from 1 hertz to 100,000 hertz. But for the most part, the infrasound region you'll hear about is about 1 to 20 hertz. For the most part, most people at normal levels of sound can't hear in that infrasonic region. Then we have the mid-frequencies between 20 and roughly 16,000, 20,000 hertz. That's our audible region. And then we have ultrasound above that. And our human hearing is very insensitive to low-frequency sounds. I'm going to try to demonstrate that. I'm going to play a tone at different frequencies, starting from the lowest frequencies. The tone is actually the same decibel level, but we're going to hear the sound at different loudness. Let's try it. Okay, that's at 50 hertz. This is at 100, 500, 1,000, 5,000, 10,000. Okay, I won't do that again. But you can see the exact same level, but the perception of the sound is very different at different frequencies. So what acoustical engineers have done is created corrections to the curves to account for that sensitivity. And the most common correction that we use in environmental sound is for moderate and low sound levels is this A-weighted correction, which we see here on this curve. So again, it discounts these low frequency sounds. For very high energy sounds, such as blasts, our ears are more sensitive to those lower frequencies, and so the C-weighted scale was developed to represent these the high energy sounds, and it's a very flat weighting, so it doesn't affect those low frequencies as much. I'll give you an example of common levels of sound in terms of decibels. This is a chart that we have the decibels on the right here, and then we have various things that are those sound levels. Most of these I've measured. And at 120, 140 decibels of sound pressure level, that gets into the range of permanent damage to your hearing. And a hard rock band comes pretty close to that. At an auto horn at 100 feet, and a lot of power tools are around 100 decibels at the ear. A riding lawnmower at the ear, about 90 decibels. Inside the car with your windows closed, traveling about 65 miles an hour is about 70 decibels. A car passed by at 50 feet is around a little over 60 decibels. Then we get to the lower sound levels. Typical suburban areas, 40 to 50 decibels. I was out here yesterday with a sound level meter, and I was outside the hotel, and that was about 55 decibels, with most of the noise coming from some HVAC units next door, but there's some distant traffic as well. In the back of the room, when nobody was here, I measured about 45 decibels, and that was mainly coming from the air handling system. And that's typical for an office or a library with an air handling system. It's about 40 decibels. In the hotel room last night, I don't know if anybody stayed in the hotel last night, but that with the fan running and on low, that was about 45. And then we get into quiet rural areas, no insects, no traffic at around 30, and some of the lowest measurements I've made in desert environments are about 20 decibels. But the limit of the threshold of human hearing is about 0. So even in a very quiet environment, there's always some sound, even if you might not perceive it. So we'll go into now sound from wind turbines. And I'll try to give you sort of an outline in a way that we typically evaluate the noise from wind farms. So first we determine the sound emissions, and then we'll go and look at, depending on the protocol, we might look at the background sound levels to look at the existing noise environment. We'll conduct some modeling to predict the amount of sound at individual receivers around the project. And we'll compare the results to standards or guidelines that are in existence. And then finally, if mitigation is necessary, we'll recommend mitigation. And all of these things I'll talk about a little bit more. So sound power, it's not the same as the sound pressure level I talked about. Sound power is the sound emissions from a wind turbine. Unfortunately, they both use the decibel scale, so they often are confused. But in any event, this is a graph of turbine output in kilowatts from 0 to a little bit over 3 megawatts, and the sound power level. And you can see as the turbine size has grown, so has the sound emissions from those turbines. But you could also see that there's also a very wide range of sound emissions from turbines in their different megawatt class. In terms of the frequency distribution of sound from wind turbines, this is a graph where now the x-axis is frequency, from the lower frequencies, the lower pitches, to the higher frequencies. And the unweighted sound level, we find that wind turbines have a generally flat sound output from, say, 20 to 300 hertz, and then they start to decline in pitch beyond that. In terms of the A-weighted sound level, or what we perceive, most of the sound is between roughly 200 and 500 hertz in here. So we'll perceive those as having the highest, essentially, loudness at those frequencies. It's important to understand that wind turbines make noise, and as some of the speakers alluded to before, I think in the early days, a lot of developers would promise inaudibility, and that was a big mistake, because wind turbines do make noise, and that's something we have to understand and have people understand. Most of the sound is generated by the blades. I'm not going to get into this in too much detail, but as air moves around the blade, back towards the end of the blade, essentially the air starts to move away from the blade. And by pulling away from the blade, it causes turbulence, and that's the sound we hear. That's what we call the broadband sound. It's the shushing sound of a fan, is that air moving away from the blade. There are some other components of sound from wind turbines that come from the hub. Both of those they're either tonal or broadband. So the tonal sounds are the individual tones that you can hear, like a piano has individual tones. You might be able to hear some tones in here as well if you listen carefully. This is a spectrogram of sound of a recording I took. Actually, this is Mars Hill in Maine. And spectrogram is a three-dimensional view of sound. This is time going from about 0 to 5 seconds, and this is frequency. And then the color intensity is essentially, color intensity is the level of sound. So you could see at about 1 second intervals, we get these mid-frequency lighter points, which is essentially the shushing of the wind turbines. And I'm going to try to play it. I don't know if it's going to come through because the background sound in here is very high. You hear it a little bit. So there are other issues that exacerbate noise from wind turbines. If the turbine spacing is too tight, you can get turbulence from one wind turbine affecting the essentially called inflow turbulence from another wind turbine. Any type of blade roughness, insects, tape that's left on the blades, those can increase the sound levels. Any type of deformations, icing and frosting also increases sound levels. When you have turbines that operate at the same exact speed, and if they're synchronized, that can also increase sound. We could have mechanical errors in pitch control, and in the older turbines were downwind, had downwind towers, and created a lot of low-frequency noise. All modern wind turbines are upwind turbines. So when we do modeling for permitting, we typically try to predict the highest sound level. It's also important to recognize that there's a range of sound levels turbines operate depending on the meteorology and the wind speed. And in one study we did, we looked at a frequency distribution of sound levels where we modeled the maximum, but then also looked at how frequent the sound levels would be at different the percentage of time you'd see different sound levels. So in this example, about 12% of the year you're within about 5 decibels of the maximum, and the 50th percentile was a bit lower than that. So what are the effects? The noise effects are similar to other sources of noise, depending on the level. Annoyance is the number one effect that's correlated with levels. There's possibly sleep disturbance effects as well at certain levels, and there are other effects that have been talked about in the literature, which I can talk about later if we have time. Annoyance is affected by non-acoustic factors, such as how one perceives the visibility of the turbines, attitude about wind energy, attitude about the developer. Compensation, whether you're compensated or not, actually affects whether you're annoyed and whether your sleep is disturbed. And experience. And I use the example, when the interstate highways first came through, there's probably a lot of people that were annoyed by that sound because they had very little experience with that type of sound. And as time went on, either people who didn't like the sound moved away, people who didn't mind the sound moved towards the interstates, but eventually the annoyance likely got less. So what do you do if the sound levels are too high? You can, if you're in the siting phase, you can increase setbacks, increase the spacing between turbines, identify quieter turbines or components. If you're either in siting or after the fact, you can put in noise control modes which lower the tip speeds to reduce sound. Or you can work on individual homes to improve insulation. Or, as I mentioned before, compensation also affects annoyance, so you can increase the number of project participants as well. New developments in sound. There are new blade designs. GE just came out with a new blade that has a good performance on noise, a 1 to 3 decibel decrease in sound. In terms of siting, we have offshore wind turbines that are becoming more popular, and offshore wind turbines have their own issues, but they tend to be farther away from human populations. In terms of effects, there are a number of cross-sectional and dose-response studies ongoing, and so hopefully we'll have some more information about essentially health effects in the next few years. And in terms of sound prediction, we have new modeling techniques that like parabolic equation modeling that can give you specific sound levels for very specific meteorological conditions. Unfortunately, I don't have too much time left, but I will say that there are standards that have been adopted in all of the New England states. I'm not sure about Rhode Island, but Maine has the site law. New Hampshire Site Evaluation Committee has precedents for sound levels on their projects, and Section 248 in Vermont has precedents for sound levels on their projects. Massachusetts has a QCD noise policy, which is being developed for specific to wind turbines, and hopefully that'll come out over the next few months. And then Connecticut has statewide noise regulations. Unfortunately, it doesn't leave me any time for shadow flicker, but I'll be happy to take questions on that as they come up. Thank you.
Thanks, Ken. I know we haven't given you guys much time to get into some pretty complicated issues, but we do want to save time for questions from the participants or the audience. Okay, sorry. Yep, there you go. Okay, last but not least, we've got Ben Hoen from the Lawrence Berkeley National Lab. What can I tell you? LBNL does some of the best work in the nation on renewable energy issues. And in 2009, Ben completed a multi-year study investigating the effects that nearby wind facilities have on surrounding property values. And since then, he's continued this work in looking at noise and other annoyance issues surrounding existing facilities. So, Ben, I won't take any of your time. Get up here and give us some background.
Thank you, Mark, and it's really a pleasure to be here today. I'm going to try to cover a lot of results, so I'm not going to delve too much into methods. Maybe we'll have to save that for later. I am pleased to report that there is some new, pretty high-quality work done in this area that I'm going to talk about today. I wasn't even aware of some of it up to about a month ago. And I would also like to report that I'm a statistician, and I tend to work in averages. And that makes it a little difficult to get down to a house-by-house level. And so there's a caveat in all this work, which is that we're looking at overall effects across large... So to dive into the literature, actually, I would like to point out that during the bottom of that valley is usually when the vote is cast to approve or deny a permit. So maybe the topic today should be sort of flattening the valley or something like that. All right, so to get back into the literature, the work that I participated in 2009 still has the largest number of transactions within a mile after construction, though there is good work that I'll talk about that is continuing on this road. The conclusions to that work were that after construction, after the wind facility was operating, property values were not statistically different property values near the turbines were not statistically different than property values away from the turbines after controlling for a variety of different characteristics. What that means in a very fancy way is that the margin of error is larger than the effect. And in statistics, that's as good as you can do. That means that the work isn't done, but that's really what we have given the data that we had available to us. The results indicate, therefore, that if there is an effect, it's relatively small or it's not concentrated. This figure captures the work kind of in general, so I'm going to spend just a little time on this and then be able to get back to this later. This looks at price changes over the development process, which is listed on the x-axis, pre-announcement, post-announcement, post-construction. And then the various curves, the various colors, depict the homes that were certain distances away from where the turbines were either eventually located or, if in the post-construction phase, were actually located. So you can see how price changes over time. Now, these prices are adjusted for inflation and a number of other characteristics in the home and the market and that sort of thing. But if you are expecting to not find an effect, what you get is a flat line across the curves, which is what we see in the areas outside of a mile. I should also point out that the reference category are homes that are outside of 5 miles and that transacted more than 2 years prior to the wind facility's announcement, which we felt that was a likely candidate to not be affected by the turbines and therefore makes a good reference category. What we can see inside of a mile is that the homes, compared to the homes outside of 5 miles, were already depressed in price. This might indicate why a wind facility was sited there in the first place. We can get into that some other time. The point, though, that we drew from this work and this particular figure is that if you are looking for an effect, what you'd find in the comparing the pre-announcement level to the post-construction level is a falling away to the curve to the right. And we didn't see that. We actually saw a slight increase. Now, that was the interpretation as of 2009 of this study. And what this told us is that post-construction, we aren't seeing a decrease in the values of the homes as established pre-announcement. In 2011, the same report was in 2010, the same report was consolidated into a paper that was submitted to the Journal of Real Estate Research, which has been peer-reviewed and accepted. It will be published later this year. And we also did some additional analysis with the same set of data. We found a similar post-construction effect, not statistically different, but we did some more analysis on the pre-construction that I'm going to present now. Basically, that blue figure, the blue curve, which is the inside of a mile effects, we found were pretty stable through the middle of the curve, but pretty unstable at its ends. That's simply because there was a smaller number of data, and in fact, and as well, those data were not as heterogeneous. So they were more likely affected by small changes in the neighborhood and things like that. What we found by doing some additional sensitivity analysis is that there could be a separate interpretation that those curves should be coming up at the end, which would give you more of that U-shaped curve. Now, this is a pretty, we're taking a lot of liberties by making that interpretation, but that is one way to interpret that same data. As well, the announcement time, which we had pushed previously less than 2 years after, maybe before announcement and an announcement, we said we could also push that back because folks in the community were aware of the facility even though it hadn't been announced by neighbors talking to neighbors. Again, a liberal interpretation of some data, but that's unfortunately we didn't have enough data to do more here. Laposa and Miller looked directly at this question of what happens after announcement, and their work concentrated on the Maxwell Ranch Wind Farm in Larimer County, Colorado. This facility was never built, but it was announced. And they tried to find an effect. They didn't have too much data to do it, and they didn't find an effect, but it was the first time that somebody specifically concentrated on this effect. Jennifer Hinman, in 2010, released her treatise. She was a master's student at Illinois State University, and it's a tome of 146 pages. Really well done. And it's ultimately going to be moved into a publication paper. I think she's working on that with a professor. She concentrated on this post-announcement pre-construction effect in a way that we hadn't done before. And she found that effects were there. They were statistically significant in the range of 6% to 12% for homes that are inside of 3 miles. So that's an average effect for all homes inside of 3 miles between -6 and -12%. That's a pretty large effect from announcement. But what she found is that if you looked at the same homes or the same group of homes after the wind facility was constructed and operating, the effect was not there. Again, evidence that there might be this period after the facility is announced but before it's constructed where folks are taking a risk-adverse stance and they are protecting themselves, both buyers and sellers, and discounting prices accordingly. Martin Heisselman and Carrie Tuttle haven't released this paper yet. I believe it has been submitted, but I'm not sure. I did see a draft, and I talked to them last week about it. This is more interesting because it focuses on an area nearby us. It's not in New England, unfortunately, but it's focusing on 3 counties that surround the Adirondack Park: Clinton, Franklin, and Lewis. Lewis County is the Maple Ridge Wind Farm that's been around for a while, and Franklin and Clinton have more recent facilities that have been developed there. They concentrated their analysis on the individual counties and found an effect that existed for Franklin and Clinton, which effectively is a pre-operation effect because only very little of their data was in the post-operation period, and almost all of it was in the pre-operation period. And then turning to Lewis County, where there was a lot of post-operation data, again, they found no effect. Again, seems to be a sign that there is this U-shaped curve. Finally, James Carter, who's got some work that's in draft form now, looked at Lee County, Illinois. It's an individual county that has multiple developments that have occurred there. He concentrated on the post-construction effect and again found nothing. Now again, these effects that are not found doesn't mean that effects don't exist, but they're just not as large as the margins of error. In the case of our study, to give you some effect, our margins of error were about 7%. So if effects do exist, they're probably going to be smaller than that in the post-construction period. So in conclusion, and the following slide is going to talk about what we don't know given this, but to conclude about what we do know given this is that support for wind facilities is generally the lowest given some research after the facility is announced but prior to its construction, and then returns to more normal levels. These are generalities. And analogously, the risk to property value impacts are larger during that period where folks can't determine the actual impacts, such as the actual noise and the actual visibility. Correlated to that is that the adverse impacts during that period have been found by researchers recently. There is also evidence that both support for and sales prices near turbines improve to more neutral levels after the facility begins operation. And more to the point, given what we have to work with currently, conclusive evidence that persistent post-construction effects from wind facilities have not been discovered despite a number of studies using a variety of statistical techniques and data sets. Okay, so that's what we know. Carol mentioned that's what we know in a nutshell, and then we have a larger nutshell of what we don't know. I feel like the shell that we don't know is getting smaller, given where we are today. There are gaps in the literature, and there's many proposals for new work. What are the influences to that valley effect? How do we decrease the level of that valley? That's a problem that needs to be addressed. But, of course, there are many reasons why that would be the case, and folks have dealt with some of them today, such as the transparency of the development process, the cooperation with the community, maybe the scale of the project, those sorts of things. Also, these were general effects that were found inside of a mile or larger distances than that. But we haven't had enough data to really close down the effects that are inside of a half mile, which was kind of the level that we were talking about today as far as sound goes. That's work that we hope to do at the lab over the next year. This is a discussion of what, but not why. And there really needs to be some good survey work as to how folks are actually valuing these various things that we think we're measuring, and whether the surveys can be lined up with the results. One of the interesting questions is, what are the effects of negative or positive press on the values of home values? Hysteria does matter. We don't have a wind facility up and we're finding an effect. So at that point, people are operating on what they believe to be the case, not what actually is going to be the case. And so press can play a big part in that. So can a process like this and the NEWEEP and DOE in general providing good information to people about what actual effects are. So that's it. Thank you very much. It's been my pleasure.
Okay, we're going to open this up to questions. I think we've got, 15 minutes? How much time do we have? Okay, it's not as much time as I'd hoped. I've got a couple of questions that were submitted in writing before the conference, which I'll go with. But if you've got a question, go up to one of the microphones, and we can take them. I think this is a great question, and really it could use a lot of thinking. And the question is, how can people and communities ensure that they are getting the best information when they don't have the resources and time and money to understand and potentially dispute the information provided by wind developers? Does anybody have a perspective on that? Jean.
Well, a lot of towns have in their, of course, in Vermont, it's strictly a statewide process. But when we're dealing with towns, a lot of towns put in their regulations a requirement that independent experts be hired at the developer's expense. And I think that's a way. I think there was some mention, maybe it was Dylan Voorhees mentioned that as a a way to bring in somebody with the expertise, because it is true, the towns they don't have the information or expertise to deal with some of these issues.
Any other thoughts? That's
Process. Oh, go ahead.
Oh, yeah, go ahead.
I was going to say a process like NEWEEP does a good job of that. I mean, the goal here is to put forward unbiased information. It's not supported by industry necessarily. It's put out there for everybody to digest, and hopefully, if folks looking at that same piece of information, they might draw different conclusions, but at least they can argue over what the research is. So I think more of these efforts improve that.
Yeah, well, at the statewide level, you have usually a Department of Public Service that represents ratepayers and the public, and at the town level, as Gene said, some municipalities require developers to pay for an independent review.
great. Thanks. Let's go with this gentleman.
Is this on?
Yes.
My question is, are there any studies out there that do a cross comparison for different electricity sources when we talk about whether it's wildlife impacts, scenic aesthetics impacts, or even property values? Have we been able to compare wind power projects with, for example, natural gas hydrofracturing, or coal mining, for example, the before announcement to post-construction?
Does anybody want to take a crack at that answer?
Nothing that has been done together. It would be perfect if you had a hydrofracking facility next to a wind facility and you could compare the properties around both of them. But there is the work that is just starting on wind turbines is huge for other disamenities. So high voltage transmission lines, power plants, you can name them, crematoriums. And so we have an idea of the level of effects for those, and so that helps to some degree. Hydrofracking is a really good one. I have a feeling that there's going to be some work that's done in that area in the future.
It's just in terms of all these are electricity sources, so they're all providing that same public benefit in terms, and transmission lines you could add as well. So they're all providing that same, what we would consider public benefit of electricity. So again, just interesting to know if any of those studies.
I can tell you that the Congress asked the National Academy of Sciences to do that very study under the 2005 Energy Act, and there's been no funding provided. So my understanding is that there's not a definitive analysis of different electricity resources and their life cycle costs. It's something we could use. This woman over here?
Is that on? Yeah, I guess it is. I guess this is a question for Jean. Hi, Jean. There's been a lot of discussion about the potential for adverse impacts to recreational uses due to scenic impact. You mentioned the AT. You're familiar with some of the controversy that's come up. I'm wondering, have you seen studies or evidence that there actually has been negative impacts to recreational uses? If so, could you cite those examples and maybe the extent to which it did have that impact? We've done the hiker surveys on some of the projects now, and these are all speculating what could happen, but what has actually happened is what I'm curious about.
Yes, I think that's an important question because there's often a fairly close correlation to aesthetic and recreational use, because a lot of, when I talk about scenic resources that we value, they are often the places that we have some recreational association with, whether it's a trail or a pond or lake or even a historic site, I suppose. So I think the two are very much intertwined, and they have slightly, probably a wind energy project, for example, is not going to prevent the recreational use, except maybe I know of instances with snowmobiling where there has been some concern that snowmobiling on a mountainside may be rerouted or banned or whatever. But usually it's not that kind of direct impact, and so the impact really is very often very much an aesthetic impact. I'm going to be canoeing on this pond, and I love the scenic beauty of this area, and it's going to affect that experience. And we do talk about experience, but experience levels of the intersection with the scenic resource. It's also, sometimes it's just driving. I mean, scenic roads that we have identified. But to answer your question about studies that really focus just on the recreational part, I don't know of any. It doesn't mean that they're not out there.
Yeah, so that would be something to keep an eye on as more wind farms are up, finding actual changes in use. Because it's very hard to explain this. As you know, I have to explain these things sometimes to our commissioners, and I'm lost because I have no way of saying this actually happens. We think it might, but we don't know it will.
I was having a little hard time hearing that last part.
I said, as you know, it's very difficult to, when you need to get the facts of the matter out in front of people, if you think something might happen, but you don't actually know if it will, because there's a lot of that to this particular state.
Yes, and of course most states do have their recreational plans. I think your Department of Environmental Conservation, is that what it's called, does look at some of the recreational resources, and I think doing that kind of planning is in advance and separately is an important thing to look at.
Okay, thank you very much.
Would you first identify yourself, and if you want to, who you're representing, or if you're just a good citizen? This gentleman here.
Okay, Jim Lydell, Cape Cod, with Clean Power Now. My question is, at this conference so far, and at many others I've attended, there's been no reference to research or results from all the other parts of the world, Europe and so forth. And, they've been through all this. And I was wondering why that hasn't happened, and would it be beneficial, or somebody doing something to get foreign research on these subjects?
I'll start and say that most of the research on impacts or dose response impacts from wind turbine noise is out of Europe. And the unfortunate thing is that there's really no funding mechanism for research in the United States regarding noise impacts. The EPA noise office closed in 1980, or it was defunded in 1981. So there's probably more, this might be controversial, but there's probably more ability to get federal funding for noise impacts on wildlife than there is on noise impacts on humans.
But did you answer my main point? That have these organizations looked at European experience? Did you answer that? I'm not sure you did.
Yeah, most of the sound research has come out of Europe, and the dose response research has come out of Europe.
And there's some work in property values that is not in contest with what I presented today that is in Europe too, but most of it actually has been done in the U.S. so far.
Let's go over here, gentlemen.
Hello, I'm Bill Vino. I'm Senior Planner at the Martha's Vineyard Commission. And I had a question for Mr. Hoen. It's unfortunate, I think, to avoid that you didn't have time to get into the methodology, because that's very important. Actually, I think there was a post-study interview that you conducted, or that was conducted with you, that you had mentioned that most of the siting of these facilities are in areas that have lower property values and weren't where people typically were. Also, from looking at the different studies or the different places that you looked at, I could only find, I think the Texas one had higher median value properties around 5 acres or more, and seemed to be places that people would retire to or went for the purpose of that setting. And it's just, most of the median values of these places were under $200,000. Martha's Vineyard has a little bit higher average threshold than that, over $500,000. So I think they're getting back to the setting. That is very instrumental in how it's perceived and how it might affect property values. And I wasn't able to extract a comparable situation from the study and all the many different settings that you looked at. And one other aspect of that might be that I think all the places you looked at had very large wind farms. And some of the things that we've experienced here in the New England area are the municipal projects, particularly, are just one or two or maybe three facilities, and being forced into a much denser locality usually. So I don't know if there's
I think we got the question.
a response to that.
All right. I think the question is, how well do the studies that have been done apply to areas where the home values are higher than the studies that have been done?
Actually, can I also amend that too? Because I think it's also, did you look at areas where where people live because of its natural beauty and lack of development?
That's actually a pretty long answer to both of those questions.
I know.
The first thing is we looked at scenic vista across our entire sample, and we found that the increase in home values as a percent for scenic vista was very stable regardless of where we were. And we had some areas that came up and down. Madison County, New York had some pretty high valued homes, over 500,000. It's not a Cape Cod scenario, but it is a scenario where we've got a pretty good distribution of homes throughout the price range. We found that scenic vista was very stable across there. And so people were valuing the quality of the view similarly, regardless of what is their value of their home as a percentage. And so that's one thing. The second is how well do the effects apply to a situation where it's an offshore visibility versus an onshore, something we can't really get to right now. We don't have work that really supports that. There are potentially different influences there. And the last question, I think, would be whether homes that are in the sample apply to other terrestrial locations where there's a difference in value, just simply a difference in value. We're looking at a percentage change in home value across our entire sample. We're effectively dealing with the fact that homes are higher and lower valued. And there's no reason to assume that even though you've got a lower valued home, you don't care that you're living next to a disamenity. Your home value itself might change less in dollars, but the percentage change should be similar. That's why the work that's done generally in hedonics is done using a percentage change as opposed to a dollar change. So we can talk more offline about methods and applicability, but that's the general answer.
Right. We're not going to be able to get to everybody's questions standing. I'm going to say that these folks will be available up here. You can corner them, but we have time for one more question from, I guess, this gentleman.
Hi, I'm Pat Quinlan, the former Associate Director of the UMass Wind Energy Center. I have a wildlife question, and that is sort of the rigor of all of this is really astounding, and I appreciate it very much. You've worked really hard with very difficult circumstances. But has anyone ever looked at the net impacts on wildlife? What you're looking at are the local negative aspects, but what we're all worried and concerned about is this balance of the global benefit versus the local impact. Has anyone looked at the offsetting impacts, the positive impacts of reduced mercury and acidification and other benefits that accrue to the same projects, and kind of done almost a similar project that Ben has done sort of in a large-scale way? Thank you.
Yeah, there have been some attempts to do these sorts of cradle-to-grave analyses, and I don't know how rigorous they really are. I haven't read them in any great depth, but they're out there. And the sort of the bottom line is that the electricity generation methods that have high extraction and transportation costs and impacts have more impacts. So when you think about coal and oil, it takes a lot to get it out of the ground. It takes a lot to get it to where you're going to burn it. Wind and hydro don't have those costs. So right there you see a difference in the amount of impact you're going to have. And then if you also balance in things like acid rain, sulfur deposition, mercury, and then global warming, you have another set of impacts that are produced by your fossil fuels and not by, say, nukes and hydro and wind. So, yeah, people have made these comparisons. Renewables come out looking, quote unquote, better than a lot of the fossil fuels. But again, the amount of rigor that's gone into these, I can't comment on that.
With that, we're going to have to wrap up the session. I want to thank all of these panelists for their insights. And then just one final note about lunch. If you have dietary restrictions, please see Catherine at the registration desk. And is there anything else we should talk about as far as lunch?
All right, so we've got box lunches out there. We're going to have our lunch speaker starting in about 15 minutes. So if you could go out, take a break and get yourself settled back in here to eat while we hear from Kevin Knobloch. We'll keep going. Thank you very much, panel. That was great.